The question is, if f of xy is equal to 1 upon x square plus log x minus log y divided by x square plus y square, using Euler's theorem, find x f of x plus y f of y, means x into partial derivative of f with respect to x plus y into partial derivative of f with respect to y. We have given that f of xy is equal to 1 upon x square plus natural log of x minus natural log of y upon x square plus y square. It can be written as 1 upon x square plus natural log can be also written like that, log of x to the base e and log of y to the base e divided by x square plus y square. Then we have to find the value of x partial derivative of f with respect to x plus y into partial derivative of f with respect to y, or we can also write down x del f del x plus y del f del y using Euler's theorem. So let us first define what is Euler's theorem for homogeneous function. If z is homogeneous function of two variables x and y of degree n, then x del z del x plus y del z del y is equal to nz, and x square del 2z del x square plus 2xy del 2z del x del y plus y square del 2z del y square, which is equal to n into n minus 1 into z. Now here in this example, no need to use this formula. We have to only use the first formula. From 1, we have f of xy is equal to 1 upon x square plus log x minus log y upon x square plus y square. So we need to first find what is the degree of this term. So let us do again in the same manner what we have done in the previous example. We have to multiply and divide by x square in numerator and denominator. Same over here. Now here, since log of y minus log of x can be written as log of y by x, so no need to do over here. We do only for the algebraic functions. Let us take 1 upon x square and 1 upon x square common from the both the terms. So what is remaining over here? It is 1 upon x square, and log of y minus log of x can be written as log of x y by x, and then x square upon x square and plus y square upon x square. If we again simplify it, this 1 upon x square can be written as x to the power minus 2, 1 upon 1 minus log y by x divided by 1 plus y by x whole square. So this total part is has the 0 degree because it is always in the terms of the fraction y by x. Y by x has degree always 0. So we can write down x to the power minus 2 is equal to f of y by x. So f of y by x has 0 degree. So ultimately, if we see the given functions as degree minus 2. So the given function is homogeneous function of degree minus 2. So we can write down here f is a homogeneous function of x and y of degree minus 2. Hence by Euler's theorem, x del f del x plus y del f del y equal to nf, here n equal to minus 2. So we can put x del f del x plus y del f del y equal to minus 2f. But we know that what is the value of f? It is 1 upon x square plus log of x minus log of y upon x square plus y square. So sometime we can also write down this answer, or sometime this may be the answer of our question. Therefore, x del f del x plus y del f del y equal to minus 2f, or which is equal to minus 2 times of 1 upon x square plus log x minus log y upon x square plus y square. This is the desired value of x del f del x plus y del f del y. Thank you.